What's up guys, my name is Jacob and today I'm going to tell you a little bit about my glider Hawkwing that I designed and built for the AE1601 balsa wood glider project here at Georgia Tech. So to start off, I'll go ahead and introduce the project requirements. The final glider must fit in a 16 by 16 inch box, must be made from the provided balsa wood planks, must remain intact during flight, must not use any propellers or dynamic controls, and must be hand thrown to a minimum distance of 20 feet. And for that requirement, horizontal distance is not counted, only the total distance forward. To make sure I meet and exceed all these requirements, I continually made an effort during the design process to make sure that my glider would meet the required dimensions, be made mostly from the provided material, be durable enough to sustain multiple test flights, and consistently provide a stable and straight flight for at least 20 feet. As a starting point to my design, I looked up existing designs of balsa wood gliders and started to note some of the key features and proportions they all had. Obviously, I didn't want to just copy an existing design, so I looked for design aspects that I could change. I ended up taking inspiration from a hawk during flight to make the wings of my glider swept forward with a slight dihedral angle. I figured that this was a safe source of inspiration because of the stable and fast flight of a hawk while gliding. I conducted further research to ensure that my glider would have a high probability of performing the way I wanted. In my research, I found that swept forward wings have been used in many aircraft, many advanced aircraft. So the main advantage of swept forward wings is their ability to prevent stalling at high angles of attack. I thought that this could help my glider have stable flights, even if I accidentally throw my glider at an angle that's too steep. The only disadvantages of swept forward wings have to do with controllability, which wasn't an issue because my glider wasn't even allowed to have dynamic controls. As far as alternatives to swept forward wings, elliptical wings would theoretically provide ideal lift efficiency, but they're way too difficult to manufacture, and besides, my swept forward wings already approximate an elliptical shape. I also implemented a dihedral angle into my wings, because in my research I found that wings with a slight dihedral angle provides substantial longitudinal stability and help keep the wings level. This means the glider would be more likely to maintain a stable and straight flight. I chose to use a relatively small vertical stabilizer in order to reduce overall weight and drag, and the lost longitudinal stability from this decision was made up for with the gain stability from the dihedral wings that I just talked about. I used the maximum wingspan of 16 inches because I thought this would allow my glider to generate as much lift as possible. While a smaller glider would cut overall weight, it would not be able to generate as much lift and would require greater precision in manufacturing and balancing. I used superglue as my adhesive because it could dry much faster than other types of glue, and it provided the most rigid bond between parts. So keeping all of my design choices in mind, I worked up a final sketch for my first glider design. I used metric units in my first sketch because I thought that would be easier to accurately measure in manufacturing. Finally, after a couple sessions in the Aeron Makerspace, Hawkwing Mark 1 was born. I made it entirely from the provided balsa wood, with a little bit of superglue as adhesive. I checked that it met the requirements of 16 by 16 inch, then went back to balance the glider before the first test flight. I used Play-Doh as a ballast to bring the center of mass of my glider just in front of the quarter cord. I wasn't sure exactly how much Play-Doh was optimal, so I based my first round of testing around this question. The first round of testing with Hawkwing Mark 1 went surprisingly well, with the glider consistently making mostly straight flights to a distance of 15 feet or more, with my farthest test flight reaching a distance of 72 feet. I determined that 1.5 grams of Play-Doh provided the ideal flight for my glider. I chose to keep my design iterations as minimal as possible as to not mess up my already well-performing glider. I noticed that the Play-Doh ballast had a tendency to fall off during test flights, which was not ideal, so because of this I decided to replace the Play-Doh with an equal mass of thumbtacks in the tip of the glider so that the ballast weight would be consistent and also add durability to my design. I also sanded down the back half of the fuselage to reduce overall weight. With these new improvements, Hawkwing Mark 2 was born. While it doesn't look much different from Mark 1, I hope that the new improvements would increase the overall consistency and performance of the glider without damaging its stability.
We good.
In the second round of testing, I found that the new and improved design did not have any significant changes to its flight path or distance. However, it was more durable and consistent than the first iteration, so I would say the design choices in my design iterations were successful. Uh, Using data from multiple test flights, I was able to experimentally determine my glider's lift coefficient, induced drag coefficient, and total drag coefficient. For the calculations, I assumed a steady level flight at sea level pressure. When test day came, I was confident that my glider would perform as expected and easily crush the minimum distance of 20 feet. Unfortunately, during a test flight right before the first round, the wings of my glider popped off the fuselage. I taped them back on the best I could, but they did not perform the way I used to. It only reached a distance of 15 feet in the first round, but I was lucky enough to be advanced into the next round where I redeemed myself. After some adjustments, including added ballast weight to the tip and left wing of my glider, the glider managed to reach a distance of 54 feet. Unfortunately, I was eliminated in the third round with a distance of 21 feet due to a bad throw. All things considered, I'm very proud of the glider I was able to produce and my ability to adapt and overcome on test day. Also, I think my glider was the only one with swept forward wings, so I'm glad I was able to produce a glider that was unique from everyone else's. If I had to do this project again, I would definitely use more super glue to prevent structural failures, but besides that obvious mistake, I would probably use larger wings to generate better lift and a thinner fuselage to reduce overall weight. Alright, that just about sums up my experience designing, building, and flying my glider, Hawkwing, for the AE1601 glider project. Thanks for watching and have a great day.